later this afternoon, so I don't want to take too much of time. Okay. All right, let's get to this chapter. This is about plant growth control. Like I said, it is about managing the size of the plant. Okay. Now, this is more important in floriculture industry because you want to make sure that your plants are compact, nice, and looking. But sometimes this may be also very helpful in transplant production. The seedling production for vegetables, you want to make sure that they're also compact and stress tolerant, a little bit like that. So there is some value even in vegetable industry, but more so for ornamental industry, for floriculture industry. But it's good to know. It's good to know what chemicals are out there that are available. So in case you need something, you can apply them. Okay, that's what we're going to talk about. So let's look at this. These are called pansies. Pansy is one of the flowers commonly grown. These are your chrysanthemums right here. Okay, chrysanthemums. In industry, these parts are more favored than this part. Although this plant looks big with a tall flower, people normally favor the smaller ones, compact ones, because they are easy to transport. They occupy less space. They are also a little bit stress tolerant. These are lanky. Sometimes even the plant falls off. It can break. There are lots of problems. You can see the same thing here. Some of the compact chrysanthemums were a little bit more bigger ones. So if you end up with such situation, you have issues like blowover, water. So let's say you have plants like this, but 1,000 of them, and you are required to water them. Sometimes it's even difficult to water them. If you hit a little bit harder, they blow out, they fall down. All kinds of problems, increased shipping costs. The quality is poor. They look a little bit leggy, tall. Customers also prefer more compact ones because it's easy for them to take apart, put it in soil, and grow it nicely, right? So this is the reason why tall, big plants are not desirable in ornamental industry. We want short, compact plants with 1 or 2 nice flowers in it. Okay, so how do you get that? How do you get to that point? The opposite is also important in some cases, but most often you prefer compact plants. So for that we use plant growth regulators. Okay, a plant growth regulator can either promote growth or retard growth. Okay, if you are using it to retard growth, they are called as plant growth retardants. Okay, but PGRs, what we call PGR, plant growth regulator, it can either increase growth or decrease growth. It can enhance flowering or abort flowers and maintain vegetative status of the plant. Both are possible with these regulators. Okay, these are considered as, by the way, pesticides. Okay, they are considered as pesticides. So whatever pesticide guidelines you have to maintain, you should use the same thing if you are using this plant growth. These are chemicals, by the way. Basically, these are chemicals that you're spraying like a pesticide. So what are the very advantages? You can control plant height. You can stimulate branching if you want more branching. You can promote flowering, early flowering. You can increase fruit ripening, or you can also enhance rooting. If you have cuttings and you want to root them, you can do that with these plant growth regulators. So there are multiple opportunities, not just for ornamental industry. Maybe if you are in the business of if you're using tomato cuttings and you want to use rooting. I've seen people using tomato cuttings and then use the rootings for that. They root them rather than buying seed. They want to propagate vegetatively. Probably you can try with these plant growth regulators. These are the variety of chemicals. Now, what I want to tell you is this name, what you're seeing here, this may be specific for US or Western continent, countries. What is important is this. This is the chemical name. This is not going to change. No matter what your trade name is in India, this is the chemical name. Okay, but here I'm showing you different chemicals and what they do for plant growth regulation. So let's start with ansimidol, ARS. It controls height of seedlings. You should only use ansimidol for seedlings. Okay, you cannot use anything else to control height of seedlings. For example, if you use bonsai, is another one in that list. It's so strong. It is going to make seedlings so tiny, and seedlings will remain tiny for a very long time, and it's end of your that cycle. So ansimidal is what is recommended for control of height of the seedlings. So why do you want to control height of seedlings? If you have a seedling this tall versus a seedling nice and compact like this, it's very easy to use this tiny seedling in transplanting. If it is so tall, it is going to fall down, break, whatever it is, not easy. So you want to control the height of the seedling. What happens? So I also talked about another approach to control seedling growth yesterday. What was that? Well, this was about a particular fertilizer. I'm giving you a clue. Nutrient. Not nitrate. Phosphorus. Seedling recipe was what, 2%, while the adult plant recipe of fertilizer was 8, phosphorus was 8%. So less phosphorus, milder temperatures will also reduce the growth of the seedlings. Okay. And then you also have, I'm just going to go through this list. Psychoseal is popular for poinsettias and geraniums. You probably don't grow a lot of them. B9 is also for height control, and this is used on bigger plants. B9 is diaminoxide. Diaminoxide versus ansimidal. Two things. Okay. Ethifon, floral. This is nothing. It releases ethylene. Ethifon releases ethylene. What does ethylene cause? Senescence, abortion. Slow flower bud abortion. It promotes sometimes vegetative growth. Okay. Here is paclobutazol, bonsai. It's very popular for growth control. It is used as a drench. You get 100% effect, but you got to be very, very careful with that. Okay. You also have something for perennials. Sometimes if you are not just growing flowers, but you are into perennials, you know, roses, things like that, you can use something called Sumagic, which is uniconazole. And here are a few of them that promote growth. These are reducing the growth, height, growth, removing flowers. But here are certain things that promote growth, and those are benzyladenine, gibberellins, ZA3, and then you also get 4 and 7C, butyric acid with GA, what we call fascination or progib. The reasons why we use this is sometimes we apply too much of bonsai, sometimes we apply too much of the growth control, and we see, oh, these plants are getting too small. How do we get rid of this problem? Then we go for these. We apply these, and then we try to recover the plants from that growth reduction phase. But I think the most common thing you probably want to know is this indole acetic acid for rooting purposes, what we call rootone. So there are all kinds of things for flower initiation, root initiation, maintaining vegetative stage, reducing the plant height, initiating the branches, things like that. These chemicals are all available, okay? But there are certain considerations, like anything, there are certain things you got to keep in mind. Timing wise, apply. The most important thing is these plant growth regulators should not be applied when plants are growing at a slow rate. You will hit them and you will make them stress and they will never grow. Make sure the plants grow and then hit them with this, so you can control the growth after some actual growth has happened. Also remember, these are not going to reduce the existing growth. These are only going to reduce the future growth. If the plant has already grown big and you hit them with plant growth regulators, nothing happens because already growth has happened, right? This is only for the new growth, all right? And almost always remember, don't go by, I'm going to apply on the 20th day after transplanting. Never do that. You have to apply these based on the physiological state of the plant. On the 20th day, the plants may be too big or too small. It doesn't matter. The day wise, it doesn't matter. You want to make sure that plants grow to a certain height, their physiological state is good, they are not stressed, then you use these things. Don't go by simple 20 days after this, 30 days after this, I apply bonsai. No, don't do that. Okay? Target, certain considerations for the target. There are drenches, there are sprays. Drench is something you apply straight into the pot or into the medium substrate. Spray is something you apply on top of the foliage. Okay? Make sure that, for example, bonsai I've shown you, that is applied as a drench. And then sometimes you also do dipping. For root on, to initiate roots, you have to dip it. One thing I would recommend is don't do like and put it aside. Just leave it at least for 10 seconds in that solution. So some of that indole butyric acid gets into the cutting. Okay, just don't do it quickly like that. All right. In terms of environment, and these are very common even for pesticides. You probably have heard about all these things, considerations when you are applying a pesticide. So So what I want to recommend is morning applications when evaporation is low is the best time if you want to spray, because when you spray them and immediately the water evaporates, the chemical dries out on the foliage and nothing happens. It has to get into the plant, and for that there's some water is needed. So apply when there is less wind, less evaporation, spray on it, it will be very nice at the time. Okay. Do not immediately add, for example, you are drenching, you apply it to the substrate or the soil, and immediately don't add water. You are diluting it, right? Just at least give a few hours for the chemical to be absorbed by the plant. Okay, couple of main things to keep in mind. Very simple stuff, but here is where I want to spend little more time. So what are the different methods? So you have plant growth regulators. They are chemicals, they are expensive. Sometimes you may not want to use them, especially if you are growing tomatoes or peppers or fruits that you eat. You know, people may not like it, may not want those chemicals residues on the fruits. So your options become kind of limited, especially if you are in vegetable crop production or fruit crop production. But there are other methods you can do, and these are some interesting methods that you can try. Okay, one of the things is genetics itself. See this microtina tomatoes, they come small. You don't need to do anything. There are semi-dwarf and dwarf varieties in tomatoes. I've seen in chilies, even I've seen in eggplants, brinjal. Even they're trying blueberries now, dwarf varieties. So look for that. If there is genetically smaller variety, maybe that's best for you. You don't need to even worry about this chemical pesticide. But there are other methods, like you can do pruning, pinching. Pinching is very common, by the way, for chrysanthemums. If you're growing chrysanthemum and you see one single plant, just pinch it at the top. Remove that apical meristem. It starts branching laterally. And then even you pinch the lateral ones and then they start branching, you can kind of create a round shaped plant. Some of them are naturally kind of like they produce a lot of lateral branches, but some of them are not. But the more you pinch, the less the flower size, because there are more flowers that are being formed. But if you are into big flower, I want one single big flower, you don't want to do pinching of the apical one. You want to probably take away the lateral ones. Dahlias is an example where you can actually create a big flower by taking away smaller buds. Okay, it's all about ornamental stuff, whatever, however you want to play with it. You know, but I want to focus on the environmental methods and the mechanical stress methods. Okay, this is actually from one of our research, very many years back, since 2002, 2003. These plants are wax begonias. It's a flowering plant, and this is petunias. Okay, and what is this number? This is EC. In what units? This is Siemens per meter. You see how EC affects plant growth, right? Now, if you want to control, I would say people may say, I want this plant, it's a big plant. But the problem with this big plant is the moment I had real trouble actually putting that plant there and taking a picture. It was falling like that. It has a big shoot, right? And the tiny part, it was like, all the time falling. The best one is this one, in my opinion. You see how compact and nice it is, easy to ship, stress tolerant. That's what is. So we were looking at how we can manipulate fertilizer concentration. Now, you tell me, why are the plants so small with that 2.77 EC? You asked the question, right? You see, look at this plant. You look at the EC, 2.7. No, when you apply more fertilizer, what happens? Osmotic stress. Remember? That's the reason. It's more like you're giving plants drought stress. Right around this is the optimum. The optimum may be different for petunias, right? It may be slightly less in this range. So it is species specific, but one of the ways you can actually control plant growth during production is by applying less amount of fertilizer. And this is what commonly done in greenhouses, ornamental greenhouses. They will not apply too much fertilizer because they know the problem. When you apply too much fertilizer, there is either excess growth or sometimes even problems too. So fertilizer, sometimes closer to the time when these plants get shipped, they even bring down the nitrogen supply. They will make sure that the plants are not getting, just a little bit of fertilizer, no more deficiencies, but a little bit of fertilizer, so too much of excess growth doesn't happen. So environmentally, you can control plant growth by simply supplying somewhat less fertilizer. In fact, mild drought is also used. not severe drought, mild drought. We want to make sure that at least the top 1 to 2 inches of the pot is dry before we add water again. So that kind of mild drought will make sure the plants are not too big. They are kind of compact and small, generally small. Okay, so you can use environment in terms of fertilizer or water. But there is also one more interesting thing. This may be possible up in the mountains or maybe in Srinagar, Kashmir areas. What we call negative diff. Diff stands for difference. It's the difference between what? It's a negative diff, day and nighttime temperature. Okay. So if the daytime temperature is, let's say, 60 degrees night Fahrenheit and nighttime temperature is 50 degrees Fahrenheit, what is the difference? 10 degrees. But it is positive number. What we are looking for is a negative diff, meaning the day is cooler than night. This can be only done in greenhouses. And I'll tell you how. So let's say this is winter. Okay. You are in hilly areas, it's winter. Outside temperature is cooler. Okay. And then in the greenhouse, probably because of the greenhouse structure, it is a little bit warmer. Because the greenhouse itself can increase the temperature, isn't it? You don't have to add any heating or anything. Inside a greenhouse, it's generally a little bit warmer than outside. So let's say outside is 55 degrees Fahrenheit, winter months. Okay. But the greenhouse remains at 65. You come in the morning, remember the side ventilation we talked about? You lift it. What happens when you lift it? The cold air comes inside, and then what happens is it kind of makes the greenhouse even cooler. So you can create a slightly cooler temperature, average cooler temperature during the day compared to average nighttime temperature by letting the cool air into the greenhouse. If you can come up with this negative diff, meaning you can make that the day, just the first 1 or 2 hours of the day, cooler than the average night temperature, the plant's response is they become nice compact automatically. That's called negative diff. It's like an environmental manipulation. Okay. Negative diff, not positive diff, negative diff. Positive diff increases growth, negative diff decreases growth. You don't want to create the entire day, but just that 1 or 2 hours in the morning between 6 a.m. and 8 a.m. If you can bring the temperature inside the greenhouse during that time cooler than the average nighttime temperature previous day, then you may be able to actually achieve this. This is another way. This has been done a lot up in the northern parts of the United States. But may be possible even here in cooler months, winter, where if you have problems of excess growth, generally in greenhouses, you can get to this and kind of reduce the plant growth in general. Okay. And the most interesting is this. This is called mechanical stress. That another method. It's actually a term for that. It's called stigmomorphogenesis. Originally, when I saw this technique, I thought maybe it's not practical, it's just theoretical. But I was surprised, actually I saw this in one of the greenhouses, and I'll explain how they do that. Mechanical stress system. Stigmomorphogenesis means you take a plant, you put same plant, 2 plants side by side. One plant, you take a small brush and you keep brushing the leaves every day, manually. It's not practical, isn't it? But let's say you keep brushing it for 2 weeks. The other plant, you don't do anything. This plant will be smaller. I'm not kidding. You see the data here. Tomato, eggplants, cucumber, squash, broccoli, cabbage. This is untreated and this is brushed. Look at the heights of the plants. This is coming from Virginia Tech. Joyce Latimer, a colleague of mine, she did this research. So by creating that mechanical stress, simply touching the plants, brushing it like that, we made those plants shorter. Now, if you have a huge greenhouse, can you brush every day everything? It's not possible, right? So I was thinking, how can you do this? And this probably is interesting, but okay. But then I went to a greenhouse where actually I saw it. They are not manually brushing it. Do you remember the boom irrigation? Remember? The boom goes from one end of the greenhouse to the other end and it is spraying water, right? Instead of water, what they did to the boom? They put a plastic sheet. They attached a plastic sheet. The sheet is this much and it's all the way along the length of the boom. And they are running that boom, and that plastic sheet is doing what? Every day it is brushing the plants. They were using this on some of these herbs. They were growing some herbs um, like thyme, things like that. I think it was thyme, and they want to make sure that they are compact. And it's simple now. They are turning on, they're pressing a button, the motor takes the boom, and with that boom, that plastic sheet is touching the plants. They do that every day, just for 10 minutes, and the plants are compact. No sprays, nothing, just with the boom. Okay, you may come up with, if you don't have a boom, still you may come up with something similar, something unrolling. Maybe two people can stand on both ends, a long pipe or something, and you have a plastic sheet, and they're just walking and brushing the plants. Just do it once a day, and then you'll keep you will control the plant height. So there are multiple ways. You don't have to really rely on plant growth regulators to control growth. But there are also genetic methods, there are environmental methods. You can use fertilizer, you can use water, you can use negative diff, but then you can also create mechanical stress. You can come up with an applied way and reduce the plant height. By controlling the plant height, these plants they branch a lot, you get a lot more flowers, they are shorter, easy to ship, they're thicker stems. People even have claimed stress tolerance and increase in photosynthesis in these plants. I have not seen the data, but they look nice, they look very good, customers like it, and they will automatically take it. So that's the benefit of plant growth regulation. It's a very small chapter. It's kind of like offshoot of what we normally talk, right? But still it's interesting and may be important in some specific scenarios in case you end up with, wow, my plants are going too big, seedlings are too tall, what can I do? You will need some information. Maybe you want to resort to plant growth regulators, okay? But having that information is useful. You have a question? No, that's what I'm trying to say. People claim actually that you get a lot more branches, right? And so you get a lot more flowers, but when we get to, again, keep in mind, this method is not recommended for if you are kind of like, I'm going, tall, high-wire peppers. How do I do that? No, you don't even do that. But for vegetables, where this becomes important is at their seedling stage. So you want to have your vegetable seedlings, the girth of the stem should be strong, good root system, right? A few nice leaves, but kind of short seedlings, so they are very good at transplanting. Compared to that, a lanky, tall plant with poor root system, it's very difficult, and as soon as you transplant, it's going to fall down, it takes some time, right? How do you create that stature? That is where this becomes important, but it is not going to affect the yield. It's actually good for transplanting, it's good for quick growing and then rapid growth as well. So that's where it becomes important in vegetable industry. It's mostly used in ornamental industry, just to create compact plants, okay? Right around 11:05, I'm going to stop it. This is the last slide. We probably will again meet here at 11:15 for the lab, 11:15 to 1ish for the pour through method. So what can we do, doctor? Can we get some parts? Do we have? Oh, we already have parts. So we'll figure out how to get the ECPH sensor here. Looks like they have something going on in the agronomy lab, and so we can't occupy that today. Okay, so we'll probably do here. I'll talk to Dr. Ashutosh Singh and see if we can get the sensors here, so I can show you how to do the pour through method. That's what we'll do. All right. Why don't you take a break in 15 minutes? Have some coffee. Yeah, sure. Concentration wise, it varies by crop and species. You have to probably talk to her. She does the research on that, so she may be able to tell you. Okay. Huh? Huh? This one? Huh? What do you want? No, this is a published paper. Oh yeah, it's free download. Why don't you write it down? Yeah, you can download. It's from a journal called Heart Science, HORT, Heart Science. That was from my master's program many years back. Just type my name, Heart Science, water use efficiency of petunia and begonia. Water use efficiency petunia and begonia, and you probably will find, oh gosh, 2004 or something, 2003 or 2004. Okay, but you'll find it online, free downloads. Heart Science is all online now, so you can get it. Okay, yeah. Inside or outside? Inside. Well, usually the expectation is that their effect is immediate and they are gone within 2 weeks. If you apply too much, they can be permanent or can be quite long, and that's why the other things I talked about, Progib and GA, that's why fascination, you apply them to recover from the damage, but you don't want it to be more than 2 weeks.
And sir, one more thing, are these chemicals detected in the analysis if done at the harvest time?
They can be. That's why you don't want to spray them at least 2-3 weeks before harvest. If it is a vegetable crop, definitely not 4 weeks before harvest. That's in the United States. I do not know the regulations here. I don't know whether you can even spray. In the US, we can't spray anything on fruit crops and vegetables when they get to the harvest stage. It's completely done. There's only a few that are approved for that. But I don't know here the situation. You can spray anything?
And sir,
So wash and eat, wash and eat. Okay. Boil your foods for bacterial, removing bacteria and wash them thoroughly. Yeah.
sir, fruits usually turn bad while transportation due to the green production. What are the measures taken?
So it's a different topic, but it depends on the fruit. It's a climacteric or non-climacteric. But if you are harvesting like strawberries, they don't ripen further. You have to harvest strawberries at the ripening stage. I think we were talking yesterday about it, right? It's better to ship them in cold transportation. Yeah, otherwise they'll rot quickly if they use because you're harvesting at advanced stage, right? Tomatoes harvest depends on your market. You should never harvest tomatoes unless they are turned at least a little bit red in color. You should never harvest at green stage, okay? Because they will never turn. But at least if they're a little bit of red in color, for long distance transportation, you harvest when they just turn red in color. For local markets, you want to harvest when they're completely red in color because it's just like 2 hours or 3 hours from where you are shipping. So they're readily available. But it all depends on market, consumers, crop, things like that. But shipping, always remember, because the heat here, the ethylene production is going to increase quickly. So you may want to either use some chemical, which is not allowed, but better would be cold transportation. Yeah. Strawberries is a big problem, and even for blueberries. Okay. All right. We'll stop here. We're going to get some break, and then afterwards we'll do some lab and